brief minutes. Thank you everyone for coming. I'll talk about the Anoma DOS and the Anoma decentralized operating system, or distributed operating system, and how it allows you to get privacy everywhere. And specifically, it does one thing that most other systems don't do, which is it gives you both data as well as function privacy, i.e. the data that you're operating on is private, but also the functions that are being invoked are private. But maybe let's start with a sort of brief interlude of why privacy actually matters. And I think this is something that we don't spend enough time on to actually explain to normal people, because I think a lot of normal people always phrase privacy as something like, oh, you would like to do tax avoidance, for example. But I would actually argue that everyone in this room should spend a lot more time explaining to why privacy matters, and I think we should focus roughly on especially the first and the last point, which is privacy is really fundamentally, it's about national/community defense. And I say community defense here because not everything is around national borders, but I think this is a very important phrasing because, so I live in Switzerland. I'm not originally from Switzerland, but one of the big realizations that you have to have as a small country is you will never be able to defend your financial system against large-scale nation-state attacks, right? And so privacy is not actually the point that you're trying to hide from your own government, but more that you're trying to build a financial system that's resilient enough, even if you're a small place, so that you can withstand larger nation-state attacks. And think about the easiest way to get Ethereum banned tomorrow is to essentially move all of US commerce onto public Ethereum. Because at day T+2, the NSA will go, this seems to be like a bad idea to open source all our financial commerce data to North Korea, right? So privacy, it's not so much as you want to hide something from your local community or your local government, rather you want to build resilient communities, resilient nations, and this is why you need privacy. The other one is fungibility of assets, i.e. you don't want to allow people to discriminate against you based on certain transaction patterns, essentially. This is actually why ZEC and these kind of assets are quite nice, because you get full asset fungibility, because you can have privacy with them. And the last one is actually for everyday usage. And I've done this experiment with my parents. Normal people will never use these systems if they can expect that their neighbors will see how much money they're making, whether they've just been to the doctor. It's and I think this is really the phrasing that I'd like everyone to take away from this, of this is how we should start speaking about privacy to normal people, because it's a much more positive phrasing of why this matters in practice. I'll just quickly skip over this. So, what is the Anoma DOS? And at the very high level, it's a distributed operating system. You can think of it as Windows 95. It runs wherever you would like it to run. So, for example, 3 days ago, we deployed this to Aurora. So it runs on Aurora now, so it comes to all NIA assets. It also runs on Arbitrum, Optimism, Ethereum. Pretty much wherever you can implement the operating system, Anoma, the DOS will run. And then on top of this decentralized operating system, or distributed operating system, you can actually build applications. And again, these applications can be as private as you want them to be, or as transparent as you want them to be. Because in the end, it's just one large RISC-0 circuit. It's a large recursive RISC-0 circuit that implements the Anoma DOS. And the nice thing that it does, it abstracts blockchains away into one unified interface. So rather than, because one of the big problems that I always had with having many chains is that I had to keep using new applications wherever I went. And with the Anoma DOS, we can just have the same application and it runs wherever you'd like it to run. If your local government wants to run a blockchain-based system, if your local government runs the EVM on a single server, we can deploy the Anoma DOS to that single server, and now all the applications that also work on Ethereum or on NIA also run on your local government instance. It's kind of the nice thing about passports and SIM cards was always that I could buy a SIM card in Switzerland and it would still work in the US. This is kind of the same thing here, where it's applications become very portable. The Anoma distributed operating system, it's an interface, not an intermediary, and I think that's very important to understand and make that distinction. It does not change the trust model. If you use the Anoma DOS on NIA, you only trust NIA. There's no Anoma chain you must interact with in order to get access to the applications. Your trust model is fundamentally just wherever the operating system runs. You can really think of this you pick the underlying hardware that you would like to run Windows 95 on, and then you can go and install Word on your locally running version of Windows 95. Yeah, it provides a level of abstraction that's compatible with existing chains and VMs. It changes the state model quite a bit. And it does so in order to be A, ZK compatible, and B, make applications way more scalable. So Anoma actually uses a system called a resource that's kind of the bridge between the account model that we sort of know from NIR and the EVM, and the UTXO model that we know from Bitcoin. And fundamentally, it enables a new paradigm of intent-centric applications. Roughly, this is the application layer stack that you can think of here. So you have underlying hardware, you have some way that all these things get connected, and then you build applications on top. Yeah, and so how do we get actually privacy on NIR here? And I would preface this with privacy using ZK, using zero-knowledge proofs rather than TEs, which I think we can have a long debate over TEs versus ZK, but I'm a much bigger fan of ZK because it provides much better long-term privacy guarantees. So yeah, Anoma, we deployed this to Aurora 3 or 4 days ago. So now we have the operating system on Aurora. Now we can start deploying applications to it. And so the first application that we're going to deploy is Anoma Pay. It's a specific application, it's a specific dApp that is now capable of running on the DOS on NIR. And the really cool thing is it gives you fully asset-agnostic privacy for any sort of transfers. So you have viewing keys, you have discovery keys. You can take any asset that exists on NIR and use Anoma Pay here in order to transfer this around privately. So where are the next steps? Sort of where are we going from here? And maybe I can actually speak a little bit more about how this practically works is that you, so when you deposit funds into Anoma Pay here on NIR, you can deposit some NIR, for example, and then they appear in your Merkle tree. And essentially, when you then want to spend them, you would take this resource, reveal the nullifier that is attached to this resource, and then generate output resources. For example, I could then send part of my resource to you. So for example, if I started with 10 NIR, I'd send 5 to you, and then I'd return 5 as as a change output to myself. If you're coming from Bitcoin land or the UTXO model, this is very familiar to you. We've done some interesting things to make the application very nice to use, because it also includes a thing called a discovery key, which I think most people underestimate actually the importance of. Because once you have private state, the question how you build user interfaces actually becomes very challenging because, well, no one really has the data, and really in order to figure out whether, for example, you have some money on a system, you have to decrypt every single system in every single resource in the system in order to figure out which resources belong to you. What we do with Anoma Pay, though, is that there's a discovery key that you upload to any indexing service. That discovery key will only allow you, the indexing service, to figure out which resources belong to you, but not able to decrypt the resources. So as a result, then the indexing service can just stream encrypted resources to you, and you locally decrypt this. I thought this was a very neat hack because, or not hack, but a very neat feature because it allows you to actually build very good user interfaces, which has historically been an incredibly big challenge given these private systems. So what's the next steps, though? So now we have private transfers simply working. And the nice thing is it's very easy to scale this out. If you want to now run a localized system in your home country or your home county, wherever you are, you can just take exactly the same stack. The user interface doesn't change. It's the same interface, but now you change your trust model. But from here, we can even go further. We can do fully private trading because we have NIR intents now, right? And so you can use Anoma Pay to drive the cross-chain intents as well as the cross-chain trades so that you just get fully private trading out of the box pretty much probably in the next 3 or 4 weeks. And I think everyone currently keeps talking about sort of the super app thesis on oh, everything is going to be the single big crypto application. And really fundamentally, I think this is sort of the first step towards it. Because I think for any technology here to get sort of large scale traction, it's going to require privacy. And privacy is very difficult to put in as sort of an afterthought. It's essentially impossible to put in as an afterthought. Yeah, this was the very brief introduction to the Anoma distributed operating system and how it brings privacy everywhere. if you'd like to learn more, you can connect with me and us over here, and you can also come to me afterwards. Thank you very much.